KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, in this class, we are going to discuss the concept of potential energy. The concept of potential energy, right? So here, in our last class, we focused on one example problem along with work energy theorem for a variable force. Work energy theorem for a variable force. In this class, we are going to focus on the concept of potential energy. The concept of potential energy. So please try to understand the word potential. Please try to understand the word potential. Then automatically you can understand what is potential energy, right? Okay. So here, if you observe carefully, the word potential suggesting that possibility or capacity for action. I'll repeat once again. The word potential suggesting that, try to digest what I am saying. The word potential suggesting that possibility or capacity for action. Capacity for action, right? Now, if you see the term potential energy, generally, whenever we see the term potential energy, we will get into our mind like stored energy. For example, if you take a stretched bowstring as an example, it possesses potential energy. But when it is released, you know very well, the arrow flies off at a great speed, right? Okay, now we are going for another example, like our earth. If you see the parts of earth, the earth's crust is not uniform, but it has discontinuities and dislocations. The earth's crust is not uniform, but it has discontinuities and dislocations, which are called fault lines. These fault lines are like compressed springs. And how the compressed spring possesses potential energy? In a similar manner, these fault lines possesses large amount of potential energy. Right? So when earthquake occurs, you know what is earthquake? What are the consequences of earthquake? Right? So when the earthquake results, these fault lines will readjust. When the earthquake occurs, these fault lines are readjust. It is the natural situation. So The potential energy is the stored energy by virtue of the position or configuration of a body. Potential energy is the stored energy by virtue. See here. So here he is giving one shape to the term potential energy. That is, the potential energy is the stored energy by virtue of the position or configuration of a body. By virtue of the position or configuration of a body, right? See here, next. The body left to itself releases the stored energy in the form of kinetic energy. The body left to itself releases the stored energy in the form of kinetic energy. Right? If you see this example, I am going back. See here. So it is what? A stretched bowstring. A stretched bowstring possesses potential energy. When it is released, when the arrow is released, what will happen? The arrow flies off at a great speed. So what is the reason here? Here the reason is it stores potential energy. The potential energy of the bow is converting into the form of kinetic energy. Okay, right. So if you observe carefully, now we are going to take another example. That is what? Natural. It is what? Right? It is what? The case of earth. Already I took earth as an example. There I discussed you about the fault lines, etc. But now we are going to generalize the situation. We are going to calculate and we are going to measure. See here. So to concrete the situation, to concrete the potential energy more, we are going to take an example, that is a body of mass small m. A body of mass small m on the surface of earth, on this planet. You know very well, whenever there is a body of certain mass, automatically gravitational force will start to act, right? So this gravitational force is right. For example, the gravitational force on a ball of mass small m is mg, that you know. Here what is small g? Is a constant. It is the acceleration due to gravity, which is constant near the earth's surface. Or one particular point. If you change the position on surface of earth, that will be different situation. But here just we are going to consider a ball of mass m, a ball or body of mass small m. So for this body or ball of mass small m, the gravitational force is mg. M is the mass, g is the acceleration due to gravity, right? Now we are going to assume this small mass, that is what? Ball, at certain height from surface of earth. So this height is very small when compared to the radius of earth. This height is very small when compared to the radius of earth. That written here, h is double less than re. So that we can ignore the variation of small g near the earth's surface, because you know what is the radius of earth? It is 6,400 kilometers. So what is the height we are taking? Maybe either 1 meter or 2 meters or maximum 10 meters. So maximum 10 meters means my intention is not to take 10 meters. But here for our discussion, the h may be 10 meters. So when compared to 6,400 kilometers, 10 meters is neglected now. That's why here throughout these 10 meters we are neglecting the variation of g. Right? Okay. So whatever we have taken, that is what? Upward direction. Vertically upward direction is positive, to be positive. That is what? sign convention, and the body is moving along positive y-axis. Positive y-axis. Okay, right. Now, let us raise the body or ball of mass small m from surface of earth to a height small h. My question is, right, if now you try to move the body or ball of mass small m from surface of earth to certain height h. That what I already told you. Then what should happen? What you have to do? You have to do some work. Why we need to do some work? Right? Because here you need to shift the body against the gravitational force. When you are doing some work against the gravitational force, where the work will go? So that I will tell you, you just listen. The work done by the external agency against the gravitational force is mgh. How it is mgh? Work is the product of force into displacement. So here mg is the force and the displacement is the height through which the body is going to taken. So that the work done by the external agency. Here external agency means, for example, you are taking means the muscular force. The force which is applied by the muscles is the key point here. So which is going to do the work? So the work done by the external agency against the gravitational force is mgh. And this work gets stored as potential energy. If you imagine the work done, the energy possessed by the body when it is on the surface of earth is as 0, when it is going to reach the height h by muscular force, the amount of work done by us is, right, the amount of work done is mgh. But the reason for this work done is external agency, that is the muscular force. This work is going to store in the form of potential energy. Right? Okay. So this is obviously is called as gravitational potential energy. Right? See here. Gravitational potential energy of an object. As a function of height h. Gravitational potential energy of an object as a function of height h is denoted by V of h. It is what? The gravitational potential energy. Gravitational potential is equal to mgh. Right? Afterwards, if h is taken as a variable, because you can change the height now. If h is taken as the variable, right? If h is taken as a variable, it is easily seen that the gravitational force equals to the negative of the derivative of gravitational potential with respect to h. So you can write that F is equal to minus d by dh of V of h is equal to minus mg. Right? So here whatever the gravitational potential energy is present for an object, that is what gravitational potential energy of an object as a function of the height h is denoted by V of h, and it is the negative of work done by the gravitational force in raising the object to that height. Is the negative of the work done by the gravitational force in raising the object to that height. Right? So why it is negative? You know very well. What is the positive work? What is the negative work? What is the zero work? What is the positive work? What is the negative work? What is the zero work? Right? That you know. Okay? So what I am saying is here F is equal to minus d by dh of V. That is what? F is equal to minus dV by dh. Minus dV by dh is equal to minus mg. So here we have to talk about the sign. That is what? Sign convention or sign. The negative sign here indicates that the gravitational force is downward. When released when released, the ball comes down with an increasing speed. Just before it hits the ground, its speed is given by the kinematic equation v square is equal to 2gh. Here actually the formula is v square minus u square is equal to 2gh. But if you drop a body freely from certain height h, that is here mentioned, in case of a body falling from height h, in case of a body falling from height h, v square is equal to 2gh. V square is equal to 2gh, right? That is. So here once again I am repeating, please note the importance of minus. The negative side indicates that the gravitational force is downward. When you release the ball comes down, when you release a ball, it comes down with an increasing speed. Just before it hits the ground, its speed is given by v square is equal to 2j, right? Specifically, I want to talk about negative sign. So, in our previous classes, you came to know what is the positive work done, what is the negative work done, and what is the zero work done. Okay, but here he didn't talk about work, but he is talking about only the force. F is equal to minus mg. Why minus? Means because the gravitational force is vertically downward. It is along negative y-axis. It is along negative y-axis, right? That's it, right? Now here, this is the final velocity of a body dropped from certain height h freely. Okay, right? So this is the velocity acquired by the freely falling body dropped from certain height h. That is v is equal to square root of 2gh, right? But at the same point, the point where it is going to touch the ground, the point where the freely falling body is going to touch the ground, the energy of a freely falling body where it is going to touch the ground is of mv square, At the same time, what is the potential energy when the body is at certain height h? When the body is at certain height h, what is the potential energy? It is mgh. It is mgh, right? So here that potential energy, whatever the potential energy it has, that potential energy is converting into kinetic energy. That is the important point we have to observe. That is energy conversion. Energy is converting from potential energy to kinetic energy. Okay, right. So this equation, what is that, of mv square is equal to mgh, shows that the gravitational potential energy of the object at height h, when the object is released, manifests itself as kinetic energy of the object on reaching the ground. So what he is saying is, the gravitational potential energy of the object at a height h will be converted, will be modified, will manifest in the form of kinetic energy just before going to reach the ground. So their potential energy is equal here kinetic energy. So there is no gain of energy, there is no loss of energy. Even like that, there is no gain of energy also. So you can say that mathematically here f of x is equal to minus dv by dx, right? It's not the new thing, already we have written in the same class. So here f of x is equal to minus dv by dx. So what this implies, right? This implies that integration xi to xf f of x dx is equal to minus integration vi to vf dv, that is equal to vi minus vf, right? So here I want to say some information that you please observe carefully, listen carefully, see this. So the notion of potential energy is applicable only to the class of forces where work done against the force gets stored up as energy. I'll repeat once again. The notion of potential energy is applicable only to the class of forces where work done against the force gets stored up as energy. Right? Okay. Next, when external constraints are removed, it manifests itself as a kinetic energy. For example, in one dimension, the potential energy is defined if the force can be written as, that's I already told you, f of x is equal to minus dv by dx. F of x is equal to minus dv by dx. Okay. So here what he is saying, here the potential energy we are talking in terms of class of forces where work done against the force gets stored up as energy. So in case of the vertically projected body also, or in case of freely falling body also, the same thing has done. So what has done here? The potential energy is converted into the kinetic energy in case of freely falling body. In case of vertically projected up body, the kinetic energy is converting into the potential energy. Right? That is. Next, see here, the work done by a conservative force. So what is conservative force? That is the question. Similarly, what is non-conservative force? Now we are going to discuss those two things. Listen carefully. The work done by a conservative force such as gravity. So gravitational force is the best example of conservative force. The work done by a conservative force such as gravity depends on the initial and final positions only. I'll repeat once again. So this is correct in case of freely falling body or vertically projected up body. This is correct in case of freely falling body or vertically projected up body, because these are the cases which are under the gravitational force. Right? Purely, see here, the work done by a conservative force such as gravity depends on the initial and final positions only. Next, in case of inclined planes, see here, if an object of mass small m is released from rest from the top of a smooth inclined plane of height h, its speed at the bottom of the inclined plane is square root of 2gh, which is independent of angle of inclination. Right? So that is the reason at the bottom of the inclined plane it acquires kinetic energy. So how much kinetic energy it acquires? How much potential energy it has? While coming or while starting, the same amount of kinetic energy it will gain. Right? So here you can say one point, that is what, if the work done or the kinetic energy, did depend on other factors such as the velocity or the particular path taken by the object, the force would be called as non-conservative. Right? So what he is saying about conservative force and non-conservative force is, if the work done by the force depends upon only on the initial and final positions of a body, means such a force is said to be conservative force. Right? Okay. Next, if the work done by a force is independent of the initial and final positions, otherwise it is depending upon the path taken by a body, or path taken by the object, or the velocity, the velocity, then it is said to be non-conservative force. For conservative force, the example gravitational force. Gravitational force. For non-conservative force, the example is frictional force. Frictional force. It is not there in our book, but we can say confidently based on our previous chapter, that is what laws of motion we got, what is friction, and next chapter we are going to, in the coming we are going to discuss about gravitation chapter, right? Anyhow, we can say that gravitational force is the example of conservative force, and frictional force is the example of non-conservative force. Non-conservative force, right? Okay, next. What is the dimensional formula of potential energy? So this is the dimensional formula of potential energy. So for energy or potential energy or kinetic energy or work, the dimensional formula is same. That is m power 1, L power 2, T power minus 2. T power minus 2. Okay, right. And then what are the units? S, joule. Joule is the SI unit of potential energy. And if you go for CGS unit, it will be egg. So the units and dimensional formulas are same for potential energy, kinetic energy, and work also. Right. Now, to reiterate the change in potential energy for a conservative force. To reiterate the change in potential energy for conservative force, delta V is equal to the negative of the work done by the force. Delta V is equal to the negative of the work done by the force. That is, delta V is equal to minus f of x into delta x. Delta V is equal to minus f of x into delta x, right? So delta V is equal to the, delta V is here, delta V is equal to the negative of the work done by the force. Negative of the work done by the force. So in the example of falling a ball or an object, in this class, we observed how potential energy was converted into kinetic energy, right? So this is the best important principle of conservation in mechanics that we are going to discuss in our next class. But in this class, we concentrated on the concept of potential energy. So we focused what is the meaning of the term potential. That is what possibility or capacity of action. Capacity of action. Then what is the meaning of the term potential energy means? So generally we are getting into our mind, it is like potential energy means like stored energy. We have so many examples. One of the best example is stretched bowstring, which possesses potential energy. If you go for earth crust, there we have fault lines. These fault lines possess lot amount of potential energy, right? A lot amount of potential energy, right? So when the earthquake occurs, these fault lines will readjust according to the natural situation. It's okay. And next, by taking a small ball of mass m, so we calculated what is the potential energy. Throughout a small height h, what is the potential energy we calculated. So that we can also do in case of freely falling body, in case of vertically projected body. But in these cases, we observed that the energy conversion also takes place. So the potential energy is converting into kinetic energy, and kinetic energy is also converting into potential energy. But there is no loss of energy and there is no gain of energy. Mathematically, we can write the force in terms of that is potential, that is minus dV by dx, gravitational potential. And here you can also write another expression which also relates the force, and that is what work done. This is what variable force. It is the work done, and it is what potential energy, right? So the work done is the difference between the initial and final position, that is what which gives the potential energy. Afterwards, we came to discuss what is conservative force and what is non-conservative force. So at last we discussed what is the dimensional formula of potential energy and what are the units of potential energy. So at final you can write delta V is equal to minus f of x into dx. Here the negative sign indicates the negative side, that is what delta V. You can say that delta V is equal to the negative of the work done by the force, negative of the work done by the force. Okay, we will continue in the next class. Thank you.